Engineering the launch vehicles that allowed America to achieve suborbital flight, Moon, was no easy task. The team of Project Mercury struggled for months, trying to combine military and aid, facing issues that had never been dealt with before. When the Mercury Redstone 1 launch failed, Project Mercury stood in silence, astounded. The rocket only made a 4-inch flight. They had designed the launch for months, but nothing had gone according to plan. Instead, they were left with a fully fueled rocket at risk of exploding. The failure was incredibly demoralizing and had been fending off critics for months, who believed the United States would never rise to them during the space race. However, failure has been a crucial part of the learning process for American spaceflight programs. The most important lesson learned by the engineers after the failure of the is that spaceflight is a hard-fought game of Project Mercury was the first of the U.S.'s crewed spaceflight programs. The project sought to send a man to space and back to Earth, preferably before the Soviet feat. For the program, Donald aircraft produced the Mercury space capsule, which would carry enough supplies for a pilot base. But one of the big questions at the time, such a capsule into suborbital flight. To achieve such a feat, NASA first experimented with the Atlas D ICBM, which at the time was considered one of the largest rockets produced in the United States. On September 8, 1959, the 5-foot-long Atlas, dubbed Big Joe, successfully launched the space capsule, yet with multiple issues. This launch vehicle and merely followed the path from the angle at which it was launched. On July 28, 1960, the project with the new Mercury Atlas I, which intended to launch the capsule into space. However, the vehicle disintegrated during ascent. The problems registered with the Atlas during the test flights weren't easy to... Therefore, NASA turned its attention to the Redstone, a fuel ballistic missile belonging to the U.S. Army. It was built by Chrysler and developed by the Army Ballistic Missile Agency in 1953. Stone launch vehicle, a quarter of the Atlas's size, would be in its suborbital test flights. These test orbital flights, and were meant to evaluate the astronaut's experience during its weightlessness period. However, On's force of thrust generated by alcohol and liquid oxygen combustion wasn't in orbital missions. This issue vehicle Jupiter-C, which carried a Redstone and 2 solid propellant upper stage. Thanks to its new lengthened tanks, the rocket could finally get necessary for suborbital flight. Since the Jupiter-C's engine was being gradually disposed of by the Army, they fired a Rocketdyne A7 engine and used safer fuel consisting of ethanol. To get to support crewed flights, the Redstone underwent over 800 additional modifications. Because the mission and scope were so new, the team from charted territory. Former and the NASA engineers ran several of the initial tests to experiment with the mixed technology they were pairing. But they used a box of electronics to simulate an astronaut's weight inside the capsule. Later on, they experimented with primates. Before the primary launch, the team put together a thorough protocol that stipulated what they theoretically should do. As Krantz explained in so many things are happening that they would not have any time for second thought. After Atlas I during the test launch, the team faced significant pressure. Project Mercury was over a year behind schedule, and its critics thought it wouldn't. One particularly scathing article in the journal, quote, NASA's Mercury manned satellite program appears to be towards a new humiliating disaster in the East-West space race. It no longer offers any realistic hope of beating Russia in launching the first man into orbit, much less to serve as an early stepping stone for reaching the moon. The test launch of the MR-1 was meant to, quote, qualify the automatic in-flight abort sensing system and the spacecraft launch vehicle ballistic mission. The mission was supposed to achieve and successfully separate the booster from the capsule. In the beginning, the preparations for the launch of the MR-1 were, and the test was actually ahead of schedule. However, upon closer examination, the engineers decided that the capsule needed which pushed back the launch day initially set on November 7th, 1960. When the day finally arrived, planned to the 2nd, After the rocket launched, in minutes. Then the Redstone would rise 130 miles in the air, back down. The team felt confident during the 16-minute-long mission. At 9 a.m. on November 21st, 1960, it occurred, and a blast was heard. Everything happened as expected. But then the engineers looking through the periscope noticed that the booster was wobbling on its pedestal. Power from the ignition stopped, and the engine shut down. It rose 4 inches and settled back into the pad. Suddenly, the escape rocket jettisoned apart from the capsule, still attached from the booster. It flew 4,000 feet into the sky, 400 yards away. The escape rocket was the only and reserve parachute from the capsule deployed, and the radio antenna was ejected. Then everything stood still. Although the posigrade and retrograde motors didn't fire, which probably prevented the pad from exploding, the failed launch produced several threats. For example, the Redstone was left unsecured on the pad, fueled and powered up. The deployed parachutes from the capsule on the sides, at the risk of getting caught in the wind and tipping the capsule. According to George Lowe, to NASA headquarters, quote, "At the time of this writing, the system is still armed and cannot be disarmed until the battery depletion during the morning of November. Capsule pyrotechnics, including posigrade, also armed." Inside the control room, engineers were equally panicked and disappointed. One question was on everybody's mind: manage a fully fueled rocket that could create great destruction. No immediate solution seemed viable. NASA engineer and flight director Chris Kraft refused the idea of propellant tanks to depressurize them, and instead decided to wait until the next day. After all, the rocket seemed to be in a relatively safe. Kraft famously declared, quote, "That is the first rule of flight control. If you don't know, don't do anything." The morning after the failed launch, the battery on the booster's destruct system was the liquid oxygen had boiled off. It was finally safe for the crew to carefully approach the Redstone, drain the and evaluate the rocket. Once in the site, the team discovered that the space capsule seemed in good condition, but the Redstone's fins and skin had suffered damage. Over 1,000 feet away, they found the launch escape tower. The MR-1 was sectioned and refitting. A disaster had been averted, but an investigation was still pending on this demoralizing failure. In only the reason behind the failure was determined. The MR-1 had malfunctioned because a power and a control cable disconnected at the wrong time. Located at the base of the MR-1, the control cable first. However, longer than expected, the power cable disconnected 29 milliseconds before. These connectors were responsible for control signals and grounding. Detached and stopped all electrical grounding. 3 amps of current flowed through the. This forced the Redstone to shut off the engine and send it to escape tower. To separate from the booster after the launch escape tower jettisoned, this did not happen. In fact, because the capsule sensors felt its own supported weight, separation from the booster was disabled. Launch escape tower also activated the parachute recovery system, which deployed followed by the main one. So it didn't elevate, and the main parachute didn't sensor any weight. It was consequently deployed. Realizing the mission was crucial for Project Mercury's evolution. Over-preparation before the tests became natural for the team, time to be ready for any possible situation that might arise. Especially useful during the flight of the Freedom 7, the first one to include. The team prepared the mission for 6 months before the launch. Eventually, the MR-1 was rescheduled for December of 1960, and the other fly until 1961. This infamous lay at the Space Orientation Center of Marshall Space Flight Center. 20 Mercury Redstones, Atlas, and Little Joe launched, none carrying astronauts. And those rockets were discarded, and Project Mercury chose to launch a vehicle, one not based on off-the-shelf technology. On April 12, 1961, Brian became the first human to journey into a single orbit. Later, American Alan Shepard reached suborbital flight. Failures like the 4-inch flight of the MR-1 proved when he said, quote, "We choose to go to the moon this things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills."